New image of 3I Atlas just shattered everything we thought we knew about interstellar comets. A revelation NASA delayed for weeks. Captured by SPHEREx at the edge of Jupiter's orbit. 3I Atlas isn't spewing water vapor like every textbook predicted, but is cloaked in a 348,000-kilometer blood-red sphere raging with carbon dioxide, venting at 70 kilograms per second, while barely releasing any water at all. Why suppress a discovery that breaks every model? Did NASA hesitate because 3I Atlas fits no theory, or because it's something no scientist dares name yet? The answer lies in the coma no one expected, and the stakes of what we're about to find. SPHEREx detection of carbon dioxide-dominated coma at 3.2 astronomical units. Inside NASA, the data had already circulated among mission leads and comet specialists. The image showed a vast blood-red shell, smooth, unbroken, and eerily symmetric. No jets, no tail, no sign of the water vapor that should have been there. It didn't match any known solar system comet. The official policy was clear. Data goes public within 60 days. But this wasn't routine. This was an object from another star, venting carbon dioxide in a way no one could explain. Outside the agency, astronomers speculated. Was the delay a matter of caution or confusion? Did the mission team need time to check calibration? Or did they hesitate because the numbers made no sense? In a field where new discoveries are usually trumpeted, the silence felt heavy. The stakes were obvious. If this was natural, comet science needed rewriting. If it wasn't, the implications reached much further. The file was now out, but the questions had only just begun. At 3.2 astronomical units from the Sun, just beyond Mars and brushing Jupiter's orbit, 3I Atlas revealed something no one expected. SPHEREx, NASA's new infrared surveyor, caught the comet in mid-August 2025, right as it should have been quietly stirring if it followed the rules. Instead, the data showed a coma of carbon dioxide so vast it dwarfed the object itself. The shell stretched 348,000 kilometers from the nucleus, nearly the distance from the Earth to the Moon, but in every direction. Not a tail, not a lopsided spray, but a sphere. The numbers defy routine. SPHEREx measured carbon dioxide pouring off the comet at about 70 kilograms per second. That's 9.4 times 10 to the 26th power molecules every second, venting into space. For water vapor, the signal barely registered. The upper limit for H2O outgassing, even at this distance, was just 4.5 kilograms per second. No jets, no blue streaks of ionized gas, no sign of the classic water-driven tail that marks most comets crossing the frost line. Instead, a blood-red fog of CO₂, dense and smooth, engulfed the object like a thermal shroud. This is not what happens at 3.2 astronomical units. In our solar system, comets wake as they approach the Sun, their surfaces warming until buried water ice starts to sublimate. That water vapor drives the show, building tails, feeding the coma, carrying dust and organics outwards. But 3I Atlas broke the pattern. Here, CO₂ dominates. The coma is symmetric, almost eerily so, with no sign of the chaotic jets or localized outbursts that water activity usually brings. The gas expands in all directions, forming a shell rather than a streamer. The scale and chemistry are both outliers. Astronomers expect some CO₂ activity, especially at the edge of the frost line, but never at this level. The production rate, the smoothness, and the sheer size of the coma, these are the details that forced a second look. If water is present, it's buried deep or locked away, invisible to SPHEREx's sensors. The numbers tell a simple story. At a distance where water should rule, carbon dioxide has taken over, rewriting the script for what a comet can be. The anomaly isn't subtle. It's measured in hundreds of thousands of kilometers, in kilograms per second, in the absence of everything familiar. Hubble's first look at 3I Atlas on July 21, 2025, set the baseline. A nucleus smaller than a kilometer wide, maybe 300 to 500 meters, hidden inside a faint, expanding coma. That estimate came from high-resolution imaging, where the team subtracted out the dust and gas to isolate the core. But when SPHEREx ran its infrared scan weeks later, the numbers didn't add up. The total reflected light at 1 micron was off the charts, far brighter than a sub-kilometer core could ever produce. If all that flux came from the nucleus, the math pointed to a body nearly 46 kilometers across. That's not a rounding error. That's a difference of nearly 2 orders of magnitude. The paradox deepened with the coma's symmetry. SPHEREx didn't see the chaotic jets or patchy plumes that mark most active comets. Instead, every angle looked the same, smooth, uniform, as if sunlight was bouncing off a perfectly distributed cloud. The reflectivity pattern was almost mirror-like, scattering light evenly in every direction. No hot spots, no shadows, no sign of the nucleus peeking through. Photometric models tried to bridge the gap. If the coma's dust grains were tiny and icy, they could scatter sunlight with high efficiency, boosting the apparent brightness without needing a giant core. But that would mean over 99% of the light reaching SPHEREx was coming from microscopic particles, not the nucleus itself. The numbers forced a choice. Either 3I Atlas hides a massive, unseen core, rivaling the largest comets ever found, or the coma is so dense and finely grained that it acts as a nearly perfect shell, reflecting and diffusing sunlight in all directions. Instrument teams on both sides ran the calculations again. The flux, the scattering angles, the dust grain sizes, every variable checked and rechecked. Yet the dilemma held. Hubble's sharp vision says small, SPHEREx's brightness says enormous, and the coma's symmetry refuses to take sides. The core question hangs in the air. Is 3I Atlas a behemoth in disguise, or a master of camouflage, its true self lost behind a veil of its own making? Mainstream comet science lines up its case with numbers and patterns, not hunches. At 3.2 astronomical units, 3I Atlas vents carbon dioxide in a smooth, globe-like shell. No jets, no tail, just a sphere of gas. The carbon dioxide outflow clocks in at about 70 kilograms per second. Water vapor, usually the main event at this distance, barely registers. Models scramble for footing. Maybe a thermal blanket of carbon dioxide keeps the surface cool, or perhaps water ice lies buried deep beneath dust, shielded from sunlight. Another option, surface chemistry so alien, it resists the usual playbook. Each theory gets a score. The carbon dioxide blanket idea fits the coma's symmetry, but it can't explain the missing water completely. Deep buried ice works on paper, but the lack of even a trickle is hard to square. Unusual chemistry? It's plausible, but evidence is thin. The artifact argument sits at the edge of the table, championed by Avi Loeb. He points to the geometry, the symmetry, the coma's eerie perfection. No tail, no hot spots. He asks if this could be a shell, not a cloud, a structure, not a process. Most astronomers don't buy it. They weigh the evidence, reproducible measurements, familiar chemistry, natural outgassing. The consensus holds, odd, but within the bounds of cosmic chance. Loeb's hypothesis scores low for evidence, high for imagination. It's not ruled out, but it's not required. ʻOumuamua's ghost lingers in the background. That object, all edges and acceleration, left scientists with more questions than answers. 3I Atlas is different. It glows, it vents, it follows physical rules, just not the ones anyone expected. Each side keeps a tally. Natural explanations. Strong, but stretched. Artifact. Possible, but unproven. The next phase, closer to the sun, more heat, more data, will tip the scales. Until then, the evidence sits in the open, waiting for the moment it leans one way or the other. In August 2025, NASA's SPHEREx telescope captured an image of 3I Atlas, revealing a 348,000-kilometer-wide carbon dioxide coma with outgassing rates around 70 kilograms per second and almost no water vapor. An unprecedented signature for a comet at 3.2 astronomical units. Weeks passed before this data was released, adding to the mystery. Hubble's earlier estimate put the nucleus at just 300 to 500 meters, but the SPHEREx brightness suggests a much larger core, possibly up to 46 kilometers, or an unusually reflective coma. Experts agree. No existing comet model predicts such a massive symmetric carbon dioxide envelope so far from the sun. Mainstream theories invoke buried ices or unique chemistry, while a minority, like Avi Loeb, raise the artifact hypothesis. Despite extensive analysis, the true nature of 3I Atlas remains unresolved. With the object now moving closer to the sun, the scientific community awaits new data. For now, 3I Atlas stands as a rare enigma, challenging what we know about interstellar visitors and reminding us that some cosmic questions remain open.